Hey everybody, and welcome to the Ron and Way show. I am Ron.
And I'm Way.
And I am Ron. And let's get started. We are your Open Source Sorcerers, and coming up on our show, we're going to chicken in with the cats. We've got Waylena's going to show us an AI-Augmented UV dome that she made. And then I've got a simple galaxy with a script and some geometry nodes to share with you all. First, let's chicken with the cats. So, just want to share a little story about this guy. This is Cricket. Our I call him the number one rooster, Rooster Primo. We have two flocks, flock one and flock two. So he's over flock one, and him and the flock were out running around the other day, and the family of hawks has raised a clutch, and the adolescent hawks came down to swoop over the chickens and harass them. And one hawk landed and was kind of going after a chicken, like in a adolescent way, because they don't know what to do. And old Cricket goes marching over there and kicked that hawk in the face, and the hawk flew away. So Cricket is our employee of the month. So,
Yay!
yeah, go Cricket. So, Waylena, how are the kitties?
The kitties are doing very well. Nothing heroic to report on. The one in the picture here, the orange one, that is Carmen. She is surprisingly the sweetest of the bunch. She doesn't misbehave, but she's very skittish and doesn't usually want to be touched. Who do we got next? Oh, that's Remy. He's always very cute for the camera, but he is quite the little stinker. He's always up to trouble, although at this point he is the old man kitty of the bunch, so he's probably sitting there thinking he wants the other two to get off his lawn. And that's Caitlin, pretending to be sweet and cute. She can be sweet and cute with humans, but put another cat in the room and she changes completely. She does not like cats.
That looks like a classic tummy rub trap.
It is. And then I think I just have some other pictures of them. Just Remy looking cute. Carmen sitting on Jeff's feet.
It's a good picture.
Yeah, her eyes are just beautiful when the sunlight hits.
Yeah.
And Caitlin looking sleepy.
Aww. Well, as we get started, if you want to find us, you can find Waylena. Why don't you tell them all about where to find you?
Sure. I can be found in lots of different places. I'm still pretty first name Googleable. I've been around for a while, over 30 years in the planetarium field, and the last 25 of that has been very Blender heavy, even back in the really old days when we didn't have an undo button, a lot of buttons at all, really. It was all keyboard shortcuts. There were no menus or anything. So I've been around for a while. I do have a blog that I promise I'm going to start resurrecting very soon, so that's Fulldome, and I also keep a lot of stuff handy on GitHub for anyone to download and check out. So little sample scripts, sample blend files, things like that.
We just made this QR code. I didn't realize I'd ever tested it. I'm just going to test that real quick. Hey, it works.
Tell them how we made it.
Oh, we made that with free open source software using Inkscape, which is a competitor to Illustrator, you might say.
Vector graphics. Yay!
Yeah. And you can find me on LinkedIn. I'm at LinkedIn. I'm also at proctorcreative.com, which is not on here, but you can get to me that through LinkedIn. Yeah. So are we ready to begin, Waylena?
Sure.
Okay, I'm going to switch over to your screen.
All right, I'm going to go ahead and bring up an example blend file. Frequently in doing work for the planetarium, I need to make a dome in Blender that I'm going to apply a fisheye image to. Usually a fisheye image that I've generated or took with my own camera, maybe not. And sometimes it's because the scene is a scene where there is a planetarium in it. In fact, there's a show I'm working on right now that has that. But also, I will take this dome, cut it into pieces, and then have those pieces assemble together in the planetarium in real time so that I can then script it to do different distortions and fly apart pieces or come together, all while maintaining the mapping of the video that's playing on that model. And it's really a neat effect. I've had a lot of fun with it. The quick and easy way to get an image on a little pretend dome is to make a UV sphere, which you do that through, well, I can, I'm not going to delete that one, just in case this all goes awry. I will go into object mode. I'm going to add mesh. I'm so used to doing this with the keyboard. I'm trying to do it with the menus. And we'll add, no,
Oopsie.
That's not what I meant to add. Delete. That's all right. Digital space, it's easy to do. I'm hitting the 3 on the number pad. My screencast keys aren't set up on this. Let me go into wireframe mode. I'm hitting tab to go into edit mode. And I am just going to select and delete those vertices. Now, the mapping for the texture is done through UV mapping, where the X and Y coordinates of the texture, the image or video or image sequence, corresponds. So it's the X and Y, it corresponds to U's and V's. Because if you called them all X and Y's, you'd be like, what X, what Y? What is she talking about? And this way, the U's and the V's are the X and the Y for the texture space. So in the UV editing tab, I have the 3D space with the model that I just made, and I have the map that it was that generated when it was created, with half of it gone because I got rid of half the sphere. Now what I need is a dome master. That's the fisheye circle inside of the square for the image. And so a quick and dirty way to I'm going to say do this, because anybody that knows Blender knows what's going to happen. I'm going to unwrap is what it's called. Unwrap to make a new UV map, and I'm going to project from view. I hit U for the shortcut for that, and I'm going to project it from bounds so that it stays inside of that square. But the problem that we have is that they're not spaced equidistantly, the rings.
Oh, so as you get out to the edge, it has less less V.
So what you get, and I made this up earlier, the image I'm applying was a test image for an effect that I was making. And I'm going to, I've already set up the material for that, where it takes the texture coordinates, the UV, then maps it, the mapping node. I just always throw it in there even if I'm not going to need it, because a lot of times I'll animate a texture and I'll do it through those. And here's where I told it was just an untitled test image. And I set it into the emission strength instead of the diffuse color. I just wanted it to be able to shine on its own, since this is just a test. And I'm going to go back into, we'll go back into the UV area to show the problem from those little guys being so close. So those lines being close means that everything here at the bottom edge is really stretched out, really distorted. Now, a lot of times when I'm making special effects in the planetarium, I can just take one of these domes and strip those up, because it's abstract stuff I'm using anyway. And so nobody's going to notice that it's all stretched out at the edges. But the thing that I'm working on right now, the project, I need to be going back and forth between the dome in my little cartoon scene and then the regular planetarium dome, and I need it to be the same thing showing, and I don't want that distortion. So what I wanted was a UV map that would be where they would be spaced out equidistantly, the rings would. And so I started a conversation with Gemini. Gemini took me down many failed pathways, and it got to the point where I could tell why I was going to fail and was saying, hey, did you consider this first? And it said, oh no, of course, this is your answer to everything, because AI is very confident even when it's wrong, and AI is very often wrong. Fortunately, it's wrong very quickly. So that lets you iterate through different potential solutions to get to one that works. But I finally said, hey, instead of trying another one of your goofy ideas, why don't we just make a Python script to create a flat circle with everything spaced out the way we want it, and get a UV map from that, and then in Python script, rearrange all those vertices into the shape of the hemisphere.
Nice.
And it worked. It worked so quickly. In fact, I've got a copy of it here. Let me go ahead and make this no longer visible. I'm just going to go over into layout here. Sorry, don't be visible. There we go. And I'm going to go into scripting. And let's see, I think I might even still have it copied. No, I don't. I copied other things. So let me open this script. Let's see. Is it? No, it's here. Here we go. So here's the script that it made. And it had its own naming conventions, but the parts that I can modify are I can modify anything because it's a Python script. I can do whatever I want. But the parts that are most important are the number of rings, the number of segments, and then the radius of the dome that I'm making. But all of the names for the objects and variables are the ones that it chose, and I didn't really see any reason to do anything different. Looked at it, it all seemed, nothing seemed to be really hinky. So I went ahead and I ran it, and it's doing exactly what I asked of it. It creates that circle, and then it creates the UV map, and then it goes ahead and rearranges everything into the shape. So let's run it, and we're going to look in the upper left. There it is. There's my nice UV dome, as it's called in here. So let's go ahead and see its map. Zoom in on it there. I use the number pad dot or period key to center the whole thing where I wanted it. And this was dense because what I was working with was pretty dense. But look at how evenly spaced.
Oh, nice.
That's just so beautiful. I was so pleased with this. Let's go ahead and apply the material, same shader right there, and we'll take a look and see how that looks.
Oh, that edge looks so much better.
That is, I was so happy when this worked, and it looked great. I was jumping around, doing a little happy dance. I was the only one in the office, so there wasn't anybody there to look at me kind of oddly. But I was very pleased with this. So I did go ahead and put it on my GitHub, so I will soon be updating my Fulldome to have a post that links to it so that anyone can grab that Python script or the model that I exported from it in case that works better. But also, well, selfishly, I did it for myself because 2 years from now, I might need to do this again and be like, oh yeah, wait, I know I did that. And I don't want to have to go through that whole conversation again. Plus, it's a personal mission of mine to start documenting more of what I do, not because, oh, I'm so great or anything, but think about this, Ron. So many of the things that we've figured out, we've done by searching.
Yeah,
We've been searching Stack Exchange and Blender Artists and so many other places. Well, those sites are searched very quickly by AI, but now people aren't posting to those sites as much.
that's true.
They're
That's
using
true.
AI, but then they're not sharing their results.
Yeah,
So years from now, what's AI going to be drawing from?
yeah, that's a really good point because I was thinking along those same lines. I'm like, AI is pretty smart now, but it's it's going to be eating its own dog food pretty quick unless we
Good way of putting it.
curate the stuff that is out there. And so I think that's right. I think you've just inspired me to actually make a blog side of my own website where I document some of this stuff. So yeah, good. Um, and as long as we're talking about websites, here's Waylina's website, fosdome.com. You want to
Which
check
hasn't been
that.
updated. Hasn't been updated in 5 years, but I'm going to get on that.
Check that
You
out,
hold
though.
me accountable, Ron.
Well, you ready
Yeah.
for some more?
I want to make this galaxy. Let's
Okay,
get cooking.
so for this galaxy, I was like, I need a real simple. I just wanted something simple. Just I didn't want a lot of lines of code, and so I had a chat with ChatGPT, and I was like, let's you know me, ChatGPT, you know what I'm into. Give me some ideas for some simple demonstrations, and we came up with this. So this code generates the galaxy. The galaxy looks kind of like this when it's generated, but I modify it with geometry nodes to style it myself. Um, so I can make this galaxy hide. We can run this code, and you'll see this galaxy here. And it doesn't have to have 2 arms. We could have like 4 arms. Let's run that. Oop. Let me get rid of that 2-armed galaxy. So there we have one with 4 arms. You've got options, or even 3 arms. Should we be see if we can make that happen? An
Oh,
unusual, highly unusual galaxy shape to find would be a 3-armed galaxy. But anyway, I'm going back to 2 because I like 2. Got kind of a barred spiral look to it. Oh, I broke everything. Hang on. Control Z. Thank goodness for Control Z. Okay, I got my spiral galaxy. And I want it looks a little too tight. You know what I'm saying? A little too uniform. Um, so what we need to do is do some geometry nodes to that. I've already made some, so I'll just kind of walk you through what I did. Whoopsie. Oh, I have to. So if you have an object and you need to make it use other geometry nodes, you have to add the geometry nodes modifier first. So let's do that. And I just did that behind our faces, so let me hide our
behind our
faces.
heads.
Whoops, up. Let me push the right buttons. Okay, there we go. Doing great on this one. Geometry nodes modifiers, that's in the modifier stack here. Add modifier, go to geometry nodes, and then you can select an existing geometry nodes, and then look at how that changes there.
Oh, yeah.
So what I've done is let's separate this into components, and we'll take it apart. So I'm gonna bypass this for a minute, and you can see that all the pieces are now more uniform. If I replace that, you'll see they spread out. So that component, we're using set position. We're going through set position. I'm doing a combine XYZ, and then I'm feeding random values into the X, the Y, and the Z. So the Z, I did not need that to be too thick, and so it's just getting minus zero point 0.2 to zero point 0.2. But the X and Y, I wanted those a little more diffuse, so they're each getting a 1, -1 to 1. So if I just glide these along, you can kind of see what happens. That there's a point at which it gets, too distorted. So that's these. That's X, Y, and Z. Let me show you Z. If I said -1 to 1, we'd have a galaxy that's like kind of thick. I don't know, maybe that's not too bad. But
Yeah, that's not too bad.
so you got another issue, which is if we are just showing points um, in Eevee. So if I said like mesh to points here, why that don't work? Oh, well, take my word for it if you. Oh, actually, let's go. There we go. There we go. Okay, in Eevee, these points are gonna render as little diamonds. Let me make them smaller. But I don't want diamonds. I want actual spheres. So there's a couple of ways to approach that. You could say switch your renderer to cycles, and my expectation was that those would become dots, but they did not. So maybe I don't know what I'm talking about. Or you could do what I did.
Are those diamonds or like billboards?
They are billboard thingies. Yeah.
Okay.
Let's do what I did. We're gonna instance on points. We're gonna use icosphere.
Nice.
And those are too fat, so let's do another combine XYZ. And and we'll control the scale with a single random value. I want them all to be the same scale, which is why I'm going to X, Y, and Z. But if I'd went with this to just straight in, oh, I guess it does work. Okay, maybe you can just go straight in.
Yeah, but you can't always count on that.
Yeah, maybe you don't need this little guy here, but I like it. Yeah, preference, style. That's how you know that I set it up and not, it's my signature. Adding unnecessary nodes. So finally, you need to set a material. The set material node is critical in your geometry nodes so that you can actually get material out. And so that material is over here, cleverly named as material 001. I'm just using an emission material instead of a what's it called, the principled shader, because I'm a simple man. I just build my materials one node at a time, like this. And notice that the strength is high. I've got a strength of 8. And then I've gone into compositing, and I've added a bloom. And did I do more stuff over here that was hidden?
Not really. No.
Okay, cool. Yeah, because I'm really good at that when I'm teaching. So neat trick, just in case you don't know this already, is that when you are in your regular old view space and you want to see what the composite result looks like, you can actually do that by changing this value here. Oh, actually, I'm hiding now, so let me fix that. Whoop, button. Let me push all the buttons. There we go. So right next to the render preview, you got that little down arrow thing. and then where it says compositor, that'll normally be disabled. You can change that to say always, and then you'll see the composite result in your render preview. So yeah, I think that's what I had to say about that. Got any questions?
No, that is brilliant.
Right. Well, thanks. Guess that's it for today.
What do you think? Yeah, what do you think you would want to do with this to change it? Would you want to divide up with texture for different colors? Would you, not to do right now, but what would you want to do? Would you want to make the bulge more bulgy in the Z direction?
Yeah, I think that's exactly where we want to go next. Is we want to differentiate colors, because typically in a spiral galaxy you're going to have different colored stars. You might have knots of like those red stars in star forming regions. You'll have like more yellow stars in the bulge. You'll have some more blue stars in the arms. You'll have dust lanes. There's a lot of details that you can add to this to make it more realistic, but this is just, I wanted something real simple just to get you started.
That's gorgeous.
You could just screenshot that script and pound it in and get the similar results.
Ron, this is lovely.
Oh, well, thank you very much.
In fact, after this gets put up, I will screenshot that script. I will recreate it, and then I can have a generated galaxy to put in my little fake UV dome.
Yeah.
How's that for meta, huh?
and then a little inset of our websites and inset of our little show here that we're doing. So yeah.
That's some serious open source sorcery. I'm loving it.
That's right. That's how we operate. My website, proctorcreative.com, Waylina's website, fostome.com. Check us out. And if we got anything else to say for the nice folks at home.
Yeah. Let me go ahead and show my GitHub. If you can go ahead and switch to my screen on there.
Sure. Here we go.
There we go. Okay, so this is me, Waylina McCauley. Waystar is the name, but there's also a Waystar company out there. I don't know what they do, but they've got a GitHub. So searching Waylina and GitHub will pull me up there. At least it's a more recent picture for me. I've got just lots of little goofy things, including some Stellarium landscapes that I made. Got my old workshop from 2019, which was, it's still good if you're not dealing with geometry nodes. So that's where that ends. But the UV dome generator that I used is in here, and you can find an exported model that I made, just EXR for playing around with that UV map trick that we did the last episode, the Python for generating, and also I included for my future self a summary of the process and a summary of the failed approaches that Gemini and I took. And I had Gemini create these summaries, and then I added little notes from Waylina in there to talk more about the process. So this is largely so that I can look back later and think, okay, why was I thinking that way? Why did I do this thing? Why did I do that thing? So that's where that came from. So I will be putting something on the Fulldome blog about that very shortly.
I like that. Very nice.
Thank you, Ron.
All right. Well, do we have anything else for the podcast?
No.
If that's what we're calling it for the show. So.
Open Source Sorcerers. I love it.
All right, y'all.
Another open source sorcery success.
Another one for the books. Everybody, have a great day. Happy blending, and we'll see you next time.